Greetings! On this section of Chapter 1.8, I'll be going over quadratic inequalities. In the past, we covered having to factor polynomials. That was in Chapter 1.6, where if we see something like this and we see that there's a 1, we can use the cross product algorithm. We say beginning times n, which is -4, and the middle is -3, and then we will list out the factors of -4, 1 and -4, 2 and -2, and then we can see that 1 and -4 does give us the -3, so we put 1 and -4. Thus, the parentheses becomes x plus 1, x minus 4. So that was on Chapter 1.6. Chapter 1.7, we went one step further from 1.6 by actually splitting out the two parentheses and setting it both equaling to 0. X plus 1 is equal to 0, and x minus 4 is equal to 0, and then we will solve for x. So I would subtract 1 to both sides, and x is equal to -1. And we would do the same thing with the plus 4, and x is equal to 4. So two solutions. For the next section, we'll be covering having to find some group of numbers that actually makes a statement true such that the polynomial is greater than 0. So if we were to make a number line to this, we need to actually find an interval notation in which the values are greater than 0. So from this point and to the left, and from this point to the right. So I'll be going over that on the following questions. Question number 1, x squared minus 3x minus 4 is greater than 0. Our goal is to solve and then write a solution in interval notation and graph the solution. Show all work. I can recognize that this is a 1, so I can use a simple cross product algorithm. 1 times -4 is -4, and an output -3 here. It's just exactly like the previous problem. So by listing out the numbers of -4, 1 and -4, 2 and -2, I can see that 1 plus -4 is also -3, which is at the bottom. So I'll put 1 and -4, and therefore we're going to say x plus 1 and x minus 4. Now, here's the catch on this section now. Instead of having to split the two parentheses up and setting it equaling to 0, now we need to actually solve the inequality. X plus 1 is greater than 0, x minus 4 is also greater than 0. And it's just like this same algorithm as a previous section. I'll have to subtract 1 to both sides, and x is greater than -1. And the same thing with this, I'll need to add 4 to both sides, and x is greater than 4. Now, we need to actually graph this to see how the solution will look like if we were to write out the interval notation. Here's the 4. Here's the -1, and I can complete the numbers from here. So it's 0, 1, 2, 3, 4, 5, and so forth. And on the left side, -1, -2, and so forth. Now, the solution mentions that x must be greater than -1, and x must be greater than 4. So in order to graph this, I'll need to keep the hole open. And since x must be greater than -1, we need to shade to the right. As for the x is greater than 4, I'll need to keep the dot open, and x needs to be greater than 4. From here, we need to actually apply test points. In the following questions, we'll be uncovering where solutions do not make sense in the inequality. Whenever there's a negation in the system, then that will be canceled out. So I'm going to say test point. Perhaps we can use 0, because 0 is between -1 and 4. So test x equals 0. And I'm also going to test anything that's greater than 4. It cannot be 4 because there's an open hole here. So I'm going to use test point 5. So test x equals 5. And then from here, I'll need to substitute. Substitute 0 in for x, so that's 0 squared minus 3 times it by 0 minus 4 must be greater than 0. A little bit of arithmetic, so 0 minus 4 must be greater than 0, and therefore negative 4 is greater than 0. Now, this is not a true statement, so that means this cannot be part of the solution. As for the x is equal to 5, I'll substitute 5 in for x. 5 squared minus 3 times it by 5 minus 4 must be greater than 0. A little bit of arithmetic, so that's 25 minus 15 minus 4 must be greater than 0. 10 minus 4 is greater than 0, and 6 is greater than 0, which is a true statement. So therefore, anything that's shaded to the right of this point is a solution. So I'm going to say, as the interval notation, since 4 cannot be touched, the interval solution is from 4 up to infinity. There's no end to this shaded region, so it will continue on forever. So the answer to this is that the interval solution is from 4. It cannot touch 4, so that's why I put a parenthesis here and not a bracket, because a bracket would indicate that the hole is shaded in, but the hole is not shaded in. So it's from 4, parentheses, up to infinity. Question number 2, x squared minus 2x minus 15 is less than 0. Solve, write the solution interval notation, graph the solution. Show all work. I can recognize the fact that this is a 1x squared. I'm going to use a simple cross product algorithm. 1 times negative 15 is negative 15. The middle is negative 2. I'm going to list out the factors of negative 15. 1, negative 15, 3, and negative 5. And we can also go the other route as well. So it's like negative 1 and 15, negative 3, and 5, and so forth. I can see that 3 plus negative 5 is indeed negative 2. So I'm going to write out 3 and negative 5. Now from here, I'm going to write out the two parentheses as x plus 3 and x minus 5. It's less than 0. Split these two up. X plus 3 is equal to 0, and x minus 5 is equal to 0. And subtract 3 to both sides. X equals negative 3, and this one is plus 5. And x is equal to 5. Make the number line. Here's negative 3, and here's 5. You can use arbitrary values for the number line. It's negative 3, negative 2, negative 1, 0, and so forth, up to 5. 6, 7, and so forth, and anything from the left. Test points. Since 3 cannot be used, I'm going to use 1 to the left, so I'm going to use test point negative 4. And then from here, negative 3, any number between negative 3 and 5 will be used as another test point. So test point, I'll use the convenient number 0. I'll need to utilize this point, so test point 6. So we'll have to test point 3 times in order to find out which one of these intervals is actually the correct solution. So test point x equals negative 4, test point x is equal to 0, test point x is equal to 6. And then from here, just substitute and then find out if the solution does make sense. Negative 4 to the second minus 2 times negative 4 minus 15. That's 16 plus 8 minus 15. And this must be less than 0. That's 24 minus 15 must be less than 0. And this becomes 9 is less than 0, which does not make sense because 9 is bigger than 0, so this is disqualified. So therefore, this will not be in the solution. What about 0? I'm going to substitute 0 in for x. 0 squared minus 2 times 0, but that's 0. Minus 15 is less than 0. This becomes negative 15 less than 0, which is a true statement. So therefore, we found out one interval notation that makes the quadratic true. What about x equals 6? Because you don't want to end the problem shortly if this side is also agreeable with the statement. 6 squared minus 2 times by 6 minus 15 must be less than 0. 36 minus 12 minus 15 must be less than 0. 24 minus 15 less than 0. And this one becomes 9 is less than 0, which is not a true statement. So therefore, this will not be part of the solution. So the interval notation is between two values, between negative 3 and 5. The fact that there's no equal sign to this inequality tells us that these two will be open holes. If it did have an equal sign underneath, then these two would be shaded in. So the interval notation solution becomes from negative 3, we put this in parentheses. If it wasn't shaded in, this will become bracket. But it's not shaded in. So we need to keep it as parentheses. So it goes from negative 3 up to 5. Again, 5 is not closed in, so we're going to use a parentheses. So that's the solution, from negative 3 up to 5. Same thing goes with this. This is a 1x squared. Cross product algorithm. 1 times 8 is 8, and the middle is 6. We're going to list out 8. So that's 1 and 8, 2 and 4. And I can see that 2 plus 4 is equal to 6, which matches the bottom. So we're going to put 2 and 4. And now the 2 parentheses becomes x plus 2 and x plus 4. Set this equal to 0 and split these two up. X plus 2 is equal to 0. X plus 4 is equal to 0. Simple algebra. X is equal to negative 2. Minus 4, and this one becomes x is equal to negative 4. Make your numbered line 0, negative 1, negative 2, negative 3, negative 4, negative 5. And here is negative 2, negative 4. The fact that this is the equal sign will tell us that this is shaded in. We just need to know how we need to make the interval notation. It could be this way, it could include this, it could include the left side. But we don't know yet. Test point. This is negative 4, so I'm going to go 1 to the left. So test point negative 5. This is negative 4 and negative 2, so I'm going to test point that. Just negative 3. And then make another test point. I usually like to use 0. So test point x is equal to negative 5, x is equal to negative 3, x is equal to 0. Substitute. So negative 5 squared plus 6 times negative 5 plus 8 must be greater than or equal to 0. So that's 25 minus 30 plus 8 must be greater than or equal to 0. That's negative 5 plus 8. And that becomes 3 is greater than 0. So that matches. So therefore, this is part of the solution. What about negative 3? So negative 3 to the second power is 9. Negative 3 times 6, negative 18 plus 8. It's negative 9 plus 8. And this becomes negative 1 is greater than or equal to 0, which is not a true statement. So this is disqualified. We can't use that. And the same thing goes with 0, 0 plus 8. So this is also part of the solution. So the interval solution goes from negative infinity up to negative 4, union 0 up to infinity.